Covalent bonding is the method used by non-metal elements and hydrogen to achieve the stability that comes with the full outer shell of electrons. Atoms do this by sharing electrons. The actual definition of a covalent bond is the attraction of the positive nuclei for their shared pair of electrons. A balance must be achieved in this bond because there is attraction between the positive nuclei and the electrons and repulsion between the two nuclei. Covalent bonding will be represented on outer electron diagrams like this one at this level, where only the outer ring of electrons are shown because these are the electrons that are actually active in the formation of the covalent bond. This is an example of this type of diagram, and you can see the attraction between the positive nuclei and the negative electrons and the repulsion between the two positive nuclei. There are 7 elements that exist as 2 atoms covalently bonded together, and these are the ones that end in gen or ein. Some of these atoms share more than one pair of electrons, which creates a double and triple bonds, as you can see here for oxygen and nitrogen. Each pair of electrons is one bond. Covalent bonds don't just exist between 2 non-metal atoms that are the same. 2 or more different non-metal atoms can also covalently bond. Common examples of this are hydrochloric acid and water. In water, the central oxygen atom shares electrons with 2 hydrogen atoms. You can see that these molecules take different shapes, and this is because the shape will depend on the number of atoms in the compound. Here's a table with the molecular shapes that you will come across at this level, and it's important to know these well. You can see that water comes under this angular or bent category because it has 3 atoms, while carbon dioxide is linear even though it also has 3 atoms. The strength of the double covalent bonds in CO2 stretches this molecule straight, so that means that the number of bonds, e.g. double or triple bonds, can also affect the shape of the molecule.